Hi everyone, so in this video we're going to do two things. Number one, this is going to be a part 2 to the part 1 video, so check that out about how amino acids may actually be disproving chemical evolution, the theory that the first cells came about by molecules just smashing together and then wow, suddenly we got a functioning cell. And we're going to answer some critiques of the skeptics from that first part, and then we're going to go over the second part, which is after you even get a functional amino acid chain, what is the chance that this chain is actually useful and falls into a useful protein that has a function and is meaningful? Because if you look at each amino acid as a building block, like a Lego block for building a Star Wars ship, then there are different types. There are 20 different types of amino acids, actually, just like we can have 20 different types of Lego bricks to build the Star Wars ship. But we must put them in the right sequence and in the right order to actually create something meaningful. Like for example, if you just take one type of Lego brick and you just put that for the entire chain, it just becomes this really long Lego brick tower. And it doesn't really do anything. You have to use the right types of bricks in the right order and the right numbers of them to get something meaningful. For example, to build a Star Wars ship, a house, so on. Now, there are many possibilities of things we can build with Lego bricks, but there are far more possibilities of nonsense that you can build with Lego bricks. Gibberish, basically. And so if you apply that to amino acids, even though they can form and we can get a chain, it doesn't mean that chain is useful. So that's going to be part 2 of this video. So if you have not watched part 1, again, I really urge you to watch it so that you can understand what we're going to talk about in this video. So if you're new to the channel, my name is Keith. I'm a biology tutor, and my goal with this channel is to equip Christians to see that your faith is rational and your faith makes sense based on the evidence. And I'm going to try to make the science as layman as possible. And this channel is also for the skeptics who are questioning Christianity and are questioning whether there even is a God. So let's get to what the critics are going to say about my first video. So notice that I used in the first video there being 350 amino acids in that chain that we want to form. Now some might say, hey, we don't need such a long chain. So what is the minimum length then of an amino acid chain? So for that, let's watch this part where there's an expert who will tell us how many amino acids we need to even get a functional protein. Because, if I have too few Lego bricks, I can't really build something meaningful. You need to give me a significant number of Lego bricks, then I can build a house or a car or something like that.
What were the chances of life arising on its own?
It's been speculated that probably there would have to be a minimum of about 250 proteins to provide minimal life function.
Okay, so he gives us there 250 amino acids as the minimal length for a protein to work and to be in the first living cells. So now we're going to take that lower number, 250, instead of 350. And so a brief recap of what we said in part 1 is that every amino acid has a left-handed variation and a right-handed version of it. Because when the amino acids form randomly, supposedly, right, in the primordial soup theory, atoms will just smash into each other and then form that amino acid. Now, why would it smash into each other to form the left-handed version arrangement of atoms? Why not the right-handed version? And that's a valid question. So actually it's going to be a 1:1 ratio of how many would be in the left-handed type of amino acid and the right-handed type. And so in this primordial soup, let's say it's in the ocean, then there will be 50% which are the left-handed, 50% right-handed, but that poses a problem because life only uses left-handed amino acids. So all the proteins you're going to find in living cells, they only use the left-handed type of amino acid. So once a right-handed one comes in, because remember, this is when there wasn't even life yet, there were no enzymes to specifically choose left-handed ones to join into a chain. And also enzymes are made of protein. So if you want to say, well, there's enzymes that could do this, well, how do you get the first enzymes? Because they are also made of protein. So the very first enzymes would have to be formed just purely by chance of the left-handed amino acids stacking on each other to form a chain that is 250 long purely by chance, even though every time we have the next amino acid that comes, it could be a right-handed one. And what's the chance? Actually, it's a 50% chance that you get the wrong one to stack on the chain. So how do you calculate the probability of forming a 250 long? The first one, let's say it's a left-handed, then the next one is 50% chance that it's another left-handed, then 50% that the third one is, and 50 times 50 times 50%. So the final answer we get is this extremely low number. So it's 0.5 to the power of 250. So another critique that people might have of the first video is that I only gave the scenario of there being one try in the whole Earth per second for 300 million years. But what if the whole ocean was filled with amino acids? And let's say that every place in the ocean that we could fit an amino acid acts as a trial site to try another chain. So here's the answer we get. If the whole ocean were filled with amino acids based on the total volume of the ocean, which is so many liters, and how big one amino acid is, that gives us around this huge number of amino acids that can be packed into the ocean. So now let's assume that we have this number of amino acids in the ocean. And every single amino acid acts as one site for a new 250 long chain to be attempted. Okay, I know that doesn't make sense physically because like once you start forming a chain, it would take up more space. And so I should be calculating way fewer reaction sites. But I'm just going to give the evolutionists a huge leg up and just assume that somehow the whole chain of 250 long can fit within the space needed for just one amino acid, because I just want to help them. And I know that the odds of what they believe in is so low. We got to help them. Okay, so we're now going to calculate if we test 1 per second for 300 million years and all of those amino acids act as a site for testing another 250 long chain that is all left-handed only, because once you get one right-handed amino acid that comes in, it just destroys the whole thing. Then we would get this number. It's less than one chain that is expected to form, and it's essentially 0. So what's that number in full numbers? Because I like it when we can see in decimal form. It really shows how small the number is. Yep, so this is the full decimal form. It's really small. And so that's already at the higher end of what the evolutionists say is the time that the first living cells formed, which is 300 million years. And we are using the smallest possible protein length, 250 long, which is necessary for even the most basic cells. And even though we fill the whole ocean up with amino acids and we allow reactions to take place so fast that we're testing out one new one per second at every single site possible in the whole ocean, plus we're removing the effects of UV damage, because UV is going to come in and destroy any chains that start forming. They're not going to last around for very long. And same for RNA, which is another problem, right? RNA, what is it? It's a simpler version of DNA. DNA is 2 strands, RNA is just 1 strand, and it carries the genetic information. So RNA is like the instruction manual that will then tell the cell what proteins to make. So yeah, RNA is another problem of how is it going to even survive and how is it even going to form, which we're going to leave for another video. So yes, we can't even form one amino acid chain that is 250 long and all left-handed. So now let's go to part 2 of this video, which is even if we could form some of them, because you could say, well, what if we got really lucky, and even though this chance is so extremely low, what if somehow during that 300 million years we managed to hit the jackpot and we managed to get at least a few proteins that are all left-handed amino acids. So here's the thing though, we have to account for the fact that most of these chains are just garbage, are just nonsense, gibberish. So I could take random Lego blocks and start putting them together in a sequence, but it may not give me anything useful. But if I'm extremely lucky and I randomly put things together, I may get a sequence that actually builds something useful like a house or a car. So what is the chance that when we randomly assemble a 250 long amino acid chain, it would actually be useful and not gibberish? Okay, so let's look at the chance of that. Okay, so what's the chance that such a chain would be meaningful, would be functional protein and not just a gibberish protein? Okay, so the probability that a random chain is actually functional is this probability. So multiplying that by the already small chance here, what do we get? Okay, so we take that chance divided by 10 to the power of 77, and that's this number. Okay, so I asked for full decimal form so we can see how it is visually, and this is the answer, right? There's 90 zeros after the decimal point and then 697. So that is the chance that we'll get even one 250 long, which is the minimum length of a protein that actually is functional and not gibberish. Yep, so that's the extremely low odds that those who believe in chemical evolution, that random molecules smashed together and then they formed the first cells, have to believe in, just to believe we can even get one functional protein. And a cell, even the most basic cell, is made up of many proteins. And you still have to address the problem of how do we replicate these proteins? We need a genetic code to carry the information. Even if you use RNA, which is like the simpler version of DNA, that's a whole nother problem that we need to have random molecules smashed together to form the RNA code. And again, we'll run into the same problem that is gibberish, because there are so many more combinations of gibberish RNA rather than useful information. And then you have to have the right proteins that will actually read the genetic code and then produce the end product proteins. So that in between step as well requires the right proteins and right enzymes to be there. And it's not just one, there's a whole bunch of enzymes that need to be there to carry this out. So I hope we can see that the calculations just show, even with the extremely long amounts of time, even giving them so many leg ups and honestly just bending the math in their favor, in the evolutionist favor, the math just shows that even with millions of years, you still can't get even a single protein that is functional. And so what's the logical conclusion? Ask yourself, where is the evidence leading us? Is it leading us to say that, yeah, evolution and chemical evolution is how the first living cells came about, and then biological evolution is what worked on those living cells? So those of you who have an atheistic worldview and you think that the first living things came about by natural processes, chemicals just smashing into each other, I urge you to rethink where the evidence is leading you. And for those of you who believe in God, for those of you who are Christians, I hope this gives you more reason and rationale that your faith does make sense, that the evidence points to the fact that there is a creator God and that life didn't just come about by random molecules smashing into each other. So if at this point you realize that, okay, chemical evolution is nonsense, then watch this video here about biological evolution and why the evidence also refutes that.